Hello and welcome to the channel, friends. AutoCAD, but with a different twist. We're gonna use just a few of the native commands, and the rest we're going to work fast and accurate with a lot of dynamic blocks which are built from scratch. So what you're gonna see is not an add-on, it's not a plugin, it's not even a ribbon for the time being. There are just dynamic blocks. And the secret, we're going to use some special commands created in Lisp, working together with those blocks, and you will witness in AutoCAD concrete beam reinforcing in this episode, resembling very much the type of work you can do, let's say, in Revit or Plan or maybe Tekla, but with the fast and accuracy and the elegance provided in detailing only by AutoCAD. Okay, so we're doing this because sometimes we lack those programs or we don't know how to use them, but we have AutoCAD and the project is required to be worked in AutoCAD. So let's face it, if you're using it, the program classically is just one step ahead before of pen and paper, so it can be pretty horrendous. So that's why we're trying here on this channel to take the things further. Okay, so we're gonna use a lot of automatizations, a lot of precise movements, and just a few of the native commands. So here we go. We have an architectural drawing, and we're going to extract. I will tell you just the basics first, and then I will be detailing the secrets in the upcoming episodes. So for the time being, we're just gonna dive in and start building from scratch 3-span beam. Okay, not very simple but not very complicated also. So we're going to choose the desired beam along with the axis, and we're going to build. Boom, voila, the elevation of the beam. We just used our first Lisp command that created automatically the elevation of that in-plan beam. Now we're going to change this. As you see, it has two cantilevers at the end, but we really don't need that for this purpose. So we're going to change it. Okay, for the sake of this exercise, in fact, we're going to change a little bit the cross section. So we're going to use parametrically the 40 and 60 centimeters in height for this beam. If we hit a region here, we will see it will update automatically. Okay, and now we're going to place the body of stirrups on all 3 spans at once with the next Lisp command. We're going to select the block, hit enter, and in 2 seconds, voila. Now, each of the span is built with one stirrup. Okay, so by default it comes with one stirrup of 8 millimeters, displayed at 10 and 20 centimeters. And the spacing is done at 1/3 of the length of each span. If we wish to change that, we can bring another command that will make it at 1.5 the height of the beam. So you will see now the stirrups, there you go, they rearranged. So now we have, because of the beam is 60 centimeters, we have 90 centimeters on each end of each span. If for some reason we can use 2H, we can also do that with another command. We choose all the stirrups, hit enter with the next command, and you will see it will change to 120. There we go. Let's leave it that way. So for this exercise, we want to use, in fact, rebar cage of 2 stirrups per section. So we're going to select the stirrups again, and we change the package of stirrups. Let's say 2 stirrups at a pace of 10 and 20 centimeters. Okay, it takes a little bit longer for the list to compute, and now we have two stirrups instead of one per package, but we want to change it from 8 millimeters to, let's say, 12 and 10 millimeters for each span. We want all the beam to have the same family of stirrups. And now we just change it to 12 and 10 millimeters. And for the entire beam, we wish to have the intermediate stirrup at a width of 17 centimeters, and we can do that in the parametric panel by choosing 17 centimeters length for this stirrup. And there you go. Now we can work a little bit for all the stirrups at once regarding the concrete coverage. So we're going to choose up 4.5, down 2.5, left side 4.5 and right side 2.5 centimeters. There you go. If we hit regen, you will see the length of the stirrup is updated. Regen plus enter. There you go. We're working for this episode in centimeters and the length in meters. Okay. Now we have the body of stirrups on the entirety of the beam. How about we bring from just one command a carcass of longitudinal bars to have a start? Okay, so we're going to select everything and write the next command, hit enter, and there you go. It just brought by default longitudinal rebars of 20 millimeters. It's just the way I built this this command, don't worry. Now we can rearrange a little bit by hand, let's say, or using a command that will slide the rebar. Okay, so let's suppose now we have, for the top rebars, we want to use two families. The one that will be in the corners of the big stirrup, and the second type with different diameter that will be inside the second stirrup. So for this purpose we need to make a little bit of native commands this time. We're going to choose these blocks, we're going to copy them and drag them down with a specific length, let's say 50 centimeters. This is just a reference for me to know how to bring them back in position. Now we're going to choose the part that comes with the full information, meaning the length of the bar and the text. Here you have on the elevation the sister of the same rebar, so to speak. We're going to use the slide command, just drag them down a little bit and then move them with the same amount of centimeters we used to copy them, because we actually want to bring them back on the elevation superimposed, right? They will have on the elevation the same position as the other top rebars. So we're going to move them with the same 50 centimeters back. So this was just a method for me to actually double the rebar, but also make them distinct from the first layer. So we're not talking about a first and second layer. We're talking about the same top layer for the beam, but we're going to use different diameters. So now, what can we do? We can actually change the shape or the diameter of each bar as we please. So for the time being, we're going to leave down the whole carcasses as you've seen. We're just going to change the diameters. We'll make this one 16 millimeters. We're going to leave this 20 and we'll make this 22 millimeters. This one and this one will be 80 millimeters. These two will be 16 millimeters. This one will be 25. And this one will be also 16. Okay, what must we do now? The rebar were brought in place with no concrete coverage. Okay, so now the user is going to make this as he wishes according to the reinforcing that will come, let's say, from the other side of the building. Okay, so we're going to pretend we know what type of carcasses will be here, and we're going to try not to have any reinforcement clashes. So we're going to choose for the bottom reinforcement the same concrete coverage left and right of, let's say, 4 centimeters. We also have a command for that will create automatically left and right. We're going to introduce two types of values, 4 and 4 centimeters. Now, as you can see on each span, the bottom rebars are with a 4 centimeters coverage, and we wish the same for at least the first rebars from the left. We're going to use a concrete coverage of 7 centimeters to the left and 0 to the right, meaning we're going to let it for the time being as it is. And we're going to repeat that for the right rebars with the same command, but this time leaving 0 at the left and 7 to the right. Okay, now we're going to overlap the first set of rebars at the middle of each span of the beam. And the second row of reinforcement will overcome 1.5 the height of the beam plus an anchorage length according to a certain concrete class. Okay, so for this purpose we actually have a notepad file that comes with the values of rebar overlapping or rebar anchorage. For this exercise I have the input in that file according to 37 class concrete. So the Lisp that we're going to use for superimposing, overlapping, and then anchorage, actually they read that file and transmit the data via Lisp to the dynamic blocks, and you will see the rebars by simply using the command will lengthen themselves and will create the overlapping by using the value of the minimum rebar implied. So if you choose the 25 and the 18, it will uses the value according to 18 millimeters, or if you're using the 20 and 25, we'll have the overlapping according of the 20 millimeters rebar in that file. Okay, so first let's just slide those two just a little bit. And now we're using the command of overlapping, which we choose one bar, the second bar, and then the reference, meaning the middle of the span, which is this red line. The yellow line represents the third, and the green lines represent 1.5 of the beam height. So these are just graphic references. They will not stay on the final file. We are now working a draft file, then we're going to turn it into an extract reinforcing file, and finally the final file, which will be actually plotted and transmitted to the client, let's say. But in this episode we're just showing how we are drafting fast the carcasses. So there we go. Now we have the overlapping. We repeat the command, the 25 and the 20 millimeters, the middle of the rebar. There we go. And finally the last one. We can make with classical move some small arrangements regarding the text. And if we dimension these bars, you will find out that this value, 96 centimeters, It's suitable for an 18 millimeters rebar, poor conditions according to a C3037 class concrete. And the same for the 20 versus 25 millimeters and so on. Okay, so now we're going to lengthen a little bit the second row of the top rebars. As I said, we're going to overcome this 1.5 length of the beam with another anchorage. Right, so according to that file, the 16 millimeter rebar will lengthen with, let's say, I think it's 58. Yeah, it's 58 centimeters. So you will find that for a concrete of C3037 for conditions, the 16 millimeters rebar must have an anchorage of 58 centimeters. So we're going to repeat the same anchorage command for both ends of the next rebar and so on. And now I think we have a full stirrup and longitudinal rebar carcasses. But because this beam has 60 centimeters in height, we must use some additional rebars, let's say of 10 millimeters, that will be placed around the middle of the section, and they will come built in with another element that will bind them together. Okay, so we have a special command for that also. It's called repartition. We're going to choose each body of stirrups from each span and hit enter, and we repeat it and we repeat it. So as you saw, the rebars are self-adjusting. We can rearrange them by hand a little bit if we want. Just slide them a little bit. And we're going to choose to have one set of links at 20 centimeters spacing, because the stirrups are coming at 10 and 20 centimeters. There we go. So we have two bars of 10 millimeters. Now we have them embedded in the next columns of, they are coming by default with 60 centimeters, but that's a little bit too long, so we're going to transform them this time parametrically in 20 and 20 centimeters at each end. And now we have on each section, as I said, two rebars of 10 millimeters with one link of 8 millimeter. We hit regen, and eventually the length of the link will be updated. For the time being, as you see, we have the bar remarks closed. The layer is closed because I want you guys to see the entire drawing with no vision problems. Okay, actually they look like this. If you open the layer, you will find it weird. This is actually the rebar mark. For the time being, it will, of course, it will not stay as you saw it. In a future episode, I will explain what it does mean, because of course it will transform in a numerical sequence from 1 to whatever it takes to complete the reinforcement schedule for this beam. So because I don't want you to be a little bit confused right now, I choose to hide for the time being this layer, but it will be opened later in this episode. We can also make a copy of these repartitions and links. Actually, I think I will change this block at some point to make it smarter and actually recognize the second end of each span. But for the time being, this is what it does. It just brings to the left and then I move it manually to the right. But it can be improved for sure, this one, because we want to make as less of as possible movements and create fast and precise the rebars. Okay, now we're going to hit regen because we really need all the data to be updated for the next chapter of this beam. And I'm talking about the updated lengths of the rebars. Okay, so it has a little bit of... Okay, now we're going to choose for the bottom rebars to have 4 of them on each span. And the top rebars will come the first corners of the bigger stirrup and the other stirrup, 2 and 2 rebars on each section. And we're gonna hit regen again. Now you can see, I will bring it closer, we have 4 rebars at the bottom and then 2 and 2 rebars for the top reinforcement. So we place the stirrups, we place the longitudinal rebars, we lengthen them according to our wishes and our needs. We just gave them the concrete coverage, we added repartitions and links, and now we are ready to build the cross section of the rebars on each section together with the labels, with the tags, okay? Just like in other programs that are 3D, we're talking about a whole new environment in Revit or Allplan, but here in AutoCAD we're trying, and with great success, to actually mimic the transfer of data from the longitudinal carcasses to the sections. And for that we have 2 commands that will place for each span the bottom rebar and the first set of top rebars in the corners of each stirrup at the bottom and in the corners of each stirrup accordingly at the top. And then for the second row of the top rebars, they will be placed with a second command inside the smaller stirrup. So remember, we gave different coverages to the carcasses. We made a specific width of the stirrup, and also we can, if we want, we can slide this one for each section as we want accordingly to the clashes of the rebars, of the incoming rebars. So we can actually make a lot of things parametrically with these sections. And you will see the cross section of the rebars will actually arrange inside the stirrups with all these variables. So that's very clever from the next Lisp, you will see. So with no further ado, let's go. We're going to choose those and just hit the first span. Boom, and now we have at the bottom 4 of 16 and the same span, the other end of the beam, 4 of 16. Then we have 2 of 18 and 2 of 20, meaning those 2, this one and this one, okay? So we're going to repeat that for the next spans. Choose the rebars, hit enter once, and then choose the span, and there you go. 20, 4 of 20 at the bottom, 2 of 20 at the top, the same 4 of 20 at the bottom, and another 2 of 25 at the top. And again the last span for the larger stirrup. Boom. And now we're going to place the second row of top reinforcement, but inside the second stirrup. Every one will be placed here for each span. Okay, so we're going to use a second special command. We're just gonna choose those two, enter for this span, just hit it, boom, now they are placed 2 of 16. Okay, and 2 of 16 on the other end of the beam, because we're talking about this one which is also 16 and this one which is also 16. Okay, so now what we can see, we can actually rearrange a little bit, this time manually or maybe even parametrically, so we can have a better vision. Okay, so it's a nice drawing, no overlapping tags. Okay, and we can continue with the second command, choosing these two and the second span. As you can see, they arranged, and we come with a little bit of manual arrangement. And the last span, the second command also, 20 and 16 on the third span. So there you go, you have a 20, right? And you have the brown is a 16. Now I'm going to open the rebar mark layer. Okay, and I'm going to hit region, and you will see the longitudinal rebars on the elevation actually via this command transmitted their data to the tags from the cross sections of the rebars. So as I said, these rebar marks are now transmitted. They're actually the same. Okay, so now we have a clear correlation, just like in the 3D programs. As I said, we're trying to mimicate via Lisp and clever dynamic blocks what you should have done if you had the opportunity in Revit, in Tekla, in Allplan, but let's say you don't have these programs available, or simply you couldn't work in them, or you don't know how to work in them. Or actually, you know, you do have the programs, but for some reason your company agreed with the client to work the project in AutoCAD. It happens. It happened to me. It happened to others. So all of these presentations come from the real life, actually. Okay. So now, if we hit one more time regen, just to make sure we have all the data updated, and because this whole beam is actually constructed out of dynamic blocks, and because I want to show you that you can have normal rebar remarks, I am actually selecting everything. I'm exploding everything. And with a special command, I will sort of kill all the fields. We have a lot of fields on this beam, right? Gathering data. We shall kill all the fields with one command at once. Now we have a simple classical drawing, but still not the final rebar mark, okay? So again, we're going to choose the entire element. We want if we want to number the bars, and we're going to apply the final Lisp. That will give, there you go, the numbers. So now we have the stirrups are 1 and 2, 1 and 2, 1 and 2. They're all the same on the same on the beam, on the same span. And if we check closely, just to make sure we have the same rebar marks on the sections, left and right of each span, we can inspect that visually. So we have a 6 and the 13 and the 10 and the 8 at the top. So the first section, the bottom is 6, the repartition is 13, at the top 8 and 10, and so on. So we have the rebar left and right, 4 and 12, and 6 and 3 on the other spans. There you go, 6, 3, 12 and 4, 12 and 4, and so on. So as I said, with a few commands, we can build this beam and we can make a correlation between the longitudinal rebars and the stirrups. And that's it, guys. That's it. This episode explained in just a few words, actually, the commands that are used to build this beam. But if you are interested, if you find this intriguing, if you want to learn more, just follow the channel. And in the next episodes, I will come back with this beam and take it again from scratch and explain each step and each command in detail. Okay? And one day, I hope, I will be able to provide you with a official platform from which you can actually download those Lisps I was talking about. Because otherwise, this channel would have not necessarily the worth I'm wishing, but half of the worth if I wouldn't be able to provide you at some point with actually the AutoCAD library of dynamic blocks and the AutoLISP that goes along with the blocks. Okay, so now this is just a demo. This channel is brand new. It's in its infancy. I'm just starting it. I want to to make you curious and learn new stuff. So that's why, if you want, just hit a like, share this video with your colleagues. Just show them we can actually make so much more in AutoCAD by using it smarter, precise, with new tools. You don't need to buy any sophisticated program, any sophisticated add-ons. You can actually build your own reinforcement library. You can use it with or without the Lisps, you will see, but better with the Lisp, because the Lisp is it's making the dynamic blocks to work together, transmit data between them, adjust the dynamic blocks faster and more precise than you would ever do by hand, which is in its turn, using the dynamics blocks, it's a huge step in front of the classical AutoCAD, which, I'm saying it again, is just one step ahead of the pen and paper. It's just an electronic drawing table, let's say, right? So if you are using AutoCAD for many years, you know what I'm talking about. It's not the fastest program. It doesn't know what it draws, right? AutoCAD is only drawing lines. It doesn't know what they represent. But if you're using it in different engineering fields, let's say like in this case, the civil engineering, be sure we now have the capabilities to make it smarter, to make it work faster, more precise. And it's not even about beating the competition or proving yourself to the boss or whatever. It's about you working all day long with a clear mind. You're just gonna take the creative and engineering decisions, and in the rest the machine will do the hard labor for you, like drawing every tiny detail but with precision and with the smallest amount of knowledge from this that you will find on this channel, and with a little bit of attention and respecting a few steps, you will be able at some point to build precise these elements. Just think how long would have taken for you to draw this beam from scratch classically, just without having, let's say, any backup resource, no reinforcement blocks in preparation, or even if you had those blocks in preparation, just think of it. You have to build elevation, you have to build each and every rebar, you have to place it manually, you have to stretch it, to measure it, to put the dimensions, to build the sections, to add the text, to measure manually and edit the text. It's crazy. It's a crazy amount of work. I mean, a veteran of AutoCAD, I think, will complete this beam, and I'm kidding you not, half a day at the best. Half a day, maybe one whole day. And I know what I'm talking about. And one medium user of AutoCAD probably will work 2 or 3 days, if I'm not exaggerating, and I don't even know how long it will take it for a beginner. I don't think it will be capable, right? So just think of that. How fast we can actually build these beams. And not only the beams, you will see on this channel the columns, the walls, the slab, the formwork. Okay? I will bring episodes explaining how it's done, how you can do it yourself, how you can build blocks, how you can use them, how you can add the Lisps, and so on. Okay? So just follow the channel if you find it interesting, and you will not regret it. I promise you. Till next time, see ya.